This video will explain how quantum mechanics is wrong. Anyone can understand what quantum mechanics is about, so here is a simplified explanation. First of all, it is a part of physics that describes how an atom works. There are only two particles that you need to know about. One is the photon, which is a particle of light. The other is an electron, which can be considered a particle that moves electricity. And finally, we have the electromagnetic field. Now you can see that I have classical and Einstein called out specifically in this description. The classical means that I'm not talking about a quantum electromagnetic field. Classical fields are represented by smooth, continuous flows of force, and quantum fields are represented by pixelated, discontinuous fields of force. And I mention Einstein here because his special theory of relativity removes the medium that electromagnetic waves propagate through. This becomes very important to this discussion, so give me a second to elaborate here. Air is a medium that allows waves of sound and enable us to communicate. If you remove the medium, you have nothing to wave. Like if you removed all the air from your room right now, you would not be able to hear me because the sound waves couldn't propagate through the air medium. So, Einstein removed the medium that electromagnetic waves propagate through, and he replaced it with the speed of the photon particle. And then he made everything else warp and bend around the speed of this photon particle. So now we think about these electromagnetic fields as fields of mathematics. If you ask what is waving when we talk about waves now, it's waves of math. Now I know that sounds weird, but this is the result of Einstein's thought experiments, which most people don't seem to have a problem accepting. And finally, the forces that we are talking about are just basic attraction and repulsion. So really it is this simple. You do not need a complex and deep understanding of quantum mechanics in order to figure out why it's wrong. And speaking of why should you spend your time to try to understand this? Now, if you're already skeptical of quantum mechanics and modern physics, you probably don't need this slide. If you watch popular videos on quantum mechanics, you might hear how it's weird and counterintuitive to understand. So then why would the best description of how nature works be weird and counterintuitive? This is what I want to help you figure out. You might also hear that it's okay that you don't understand it because even the best physicists like Richard Feynman didn't understand it. This type of quote here is generally associated with something that Richard Feynman said. So let's watch the original clip.
There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't believe there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on before he wrote his paper. But after people read the paper, a lot of people kind of understood the theory of relativity in some way or other. But more than 12. On the other hand, I think I can safely say that nobody understands quantum mechanics.
So you can see that this quote in context is that it's part of a joke. But there still is some truth behind this joke. So the reason why quantum mechanics is weird and counterintuitive is because it is wrong. And when I say wrong, I mean there are mathematical mistakes and logical contradictions or paradoxes that are built into the foundation of this physics. And the failure to build a quantum computer will help prove this. Yes, they are fake, and the reason is because quantum state superposition is not real. Quantum state superposition is the Achilles heel for quantum computers. If this doesn't work, then quantum computers will fail. So this statement right here is pretty much the punchline on why quantum mechanics is wrong and why quantum computers will never work. And finally, this will serve as an example of why you can't just believe in science or scientists. You should be able to increase your own understanding enough to where you can question paradoxical or logically contradicted statements such as wave-particle duality, and complex math can be quite intimidating. But just realize that math is a way of describing a concept or a set of concepts that you can understand. So let's focus on the photon light particle. This is absolutely the biggest problem with quantum mechanics. The simple question that you can ask any physicist is, what is the definition of a single photon particle? It sounds easy enough to answer that, but I'm telling you, there is no answer because of this. The standard definition for a photon is based upon its energy, or E in this equation. And the photon's energy is proportional to its frequency, or F in this equation. And the kicker here is that this equation is a wave equation. It describes the behavior of waves and not a particle. So this is where wave-particle duality comes from. We're thinking about particles, but the math is using wave equations. Now let me show you how to illustrate this using a 3 Hertz frequency example. Anyone can draw a visual representation of this wave equation. You can see we have 0 to 1 second represented on the x-axis. Instead of looking at this as a mathematical sinusoidal waveform, we can easily visualize it as waves of water. The x-axis would represent the surface of the water if it was calm and there were no waves. You can see the 3 wave peaks that happen within the 1 second period of time. So water is the medium that has been disturbed, and the effect of that disturbance are these waves. So now we have a frequency of 3 waves in 1 second of time. In other words, 3 Hertz. Now the 3 Hertz frequency needs to be multiplied by this letter H. So let's put an H by each one of these wave fronts. So each one of these H's represents the energy of each one of these waves. To follow on with our water analogy, I put them by the wave front because when we get hit by waves of water, we can feel the energy of the wave itself. Now, if you're to think of this as a particle of light or photon, you would somehow have to stretch this photon to be 1 second long in order to encapsulate the energy of this wave equation. So do you really think that photon particles are 1 second long? Because 1 second at the speed of light is 300 million meters, which is basically from here to the moon. If scientists use this equation to define a single photon, then I hope you can see that they've gone off the deep end. And I hope you can see how you can easily debunk this idea. And there's no question that this is an embarrassingly simple mistake. Mainstream science generally tells us that Einstein's explanation of the photoelectric effect proves the particle nature of light, or the photon. This is not a correct statement, and I go into much greater detail in this video called The Quantum Flaw. And around the 3146 time frame in that video, I specifically start talking about the photoelectric effect. Here is a real quick summary. We just learned about the problem with this photon energy equation, and that it is a 1-second wave equation. When certain frequencies of light are shined onto metal, then electrons are ejected from that metal. That's the photoelectric effect. The problem is that the photoelectric effect happens right away without delay. And you know, in order for the photon energy to be created, it takes 1 second worth of time because it's based upon this frequency term. That's a huge contradiction. This is Albert Einstein's 1905 photoelectric paper. In this third paragraph, this is where he starts to talk about wave-particle duality. He says the wave theory of light has proved itself splendidly and will probably never be replaced by another theory. But that wave theory may lead to contradictions when applied to the phenomena of production and transformation of light. This is where the particle nature or photon of light comes into play. So then the simple question would be, if light is produced in discrete chunks, then when or how does it turn into a medium for waves to propagate through? I've not been able to find an answer to that, and I'm not sure it exists. So you can see the duality this sets up. In other words, light acting like a wave through a medium versus a particle projectile of light, which are not compatible with each other. And then a few months later, in 1905, Einstein released this paper, which is now considered special relativity. In this paper, he talks about the light medium that is required for wave theory, and then he takes it away with this theory. He says the introduction of a light ether, or that is what they called the light medium, will prove unnecessary. So in one paper he says the wave theory of light will probably never be replaced by another theory, and then a few months later he's changing the wave theory of light by removing the medium for which light propagates. And he replaces it with his own theory based upon the speed of the photon particle through empty space. And then that leaves the wave theory of light with a medium of mathematics. We're now waving mathematical fields. What the heck is he trying to do here? But that's wave-particle duality. It's confusing. Okay, so the last thing I want to mention is the 1923 Compton scattering experiment. And it definitely is a very compelling experiment for the idea of a photon particle of light. I don't have anything further to say about Compton scattering because I have not spent time with this experiment yet. But an experiment that anyone can do is the double slit experiment, and this is the absolute best experimental evidence against the existence of photons. So here is the basic setup for this experiment. We have a red laser pointer and a diffraction slide. The red laser pointer is a 650 nanometer wavelength. The diffraction slide was purchased from Amazon and is made by 3B Scientific. And here's a close-up of the diffraction slide. So now we can see the wave interference pattern that is created when the coherent light source, or the laser, is shot through this diffraction slide or through the double slit. You have the highest intensity light near the middle, and then you can see the bands of destructive interference where there is no light. So these waves interfered with each other and canceled each other out. And then bands of constructive interference where the light waves add to themselves. So light being a wave through a medium which causes an interference pattern explains this experiment logically. It only gets weird when you add in Einstein's confusion around photon particles and the illogical concept of wave-particle duality for light. So let's go ahead and play along with the idea of the photon particle applied to this experiment. There are plenty of videos that already go into detail about the double-slit experiment, but this Dr. Quantum animation seems to be a very popular one. And you can see right here, if you are shooting the idea of photon particles through the double slit, you would end up with two dots or two bands as shown here. But when you do the experiment in real life, you don't see the two bands of these photon projectile particles. So then how do you explain photons making this interference pattern? It is because the photons are in a quantum state superposition. And while in that state, a single photon can pass through both slits at the same exact time and interfere with itself. This allows us to see the photon particles in an interference pattern like this because it is in a quantum state superposition at this time. So if the photon's quantum state superposition were to decohere right now, then it would go back to the two blobs that we saw on the Dr. Quantum picture. As you can see, this is some of the quantum weirdness that people talk about. Sure, it's weird, but it's because it's wrong, not because this is how nature works. So from a particle perspective, you're looking at a fully cohered quantum state superposition of photons. What I'm going to do now is add more noise to this environment to try to decohere this quantum state superposition of photons. Now, why would I do this? This is why quantum computing is not working, is based upon noise in the environment. Quantum computers are not working because they are having trouble maintaining quantum state superposition. And their reasoning is because there is external noise in the environment that is decohering the superposition that they're trying to maintain inside these computers. So why am I able to maintain this quantum state superposition of photons? So someone that understands the story of quantum physics would probably think I'm an idiot for using a heat gun, because in order to collapse the quantum state superposition, I need to measure the photons, not try to heat them up. So if you try to measure which slit the photon passed through, then that will collapse the photon's quantum state superposition. It makes sense because somehow photon particles of light know when they're being measured. Yeah, sure, right. This is confusing because it's wrong. I want to mention these variations of the double slit experiment because they seem to be very popular. First of all, the which way did the photon go experiment was a thought experiment. Try to find a single photon detector that can detect which side a single photon went through. Again, try to find the definition of what a single photon is. None of this exists. You might see some of these experiments using polarizer material to mark photons as they go through each slit. But this is physically interfering with the light waves. It has nothing to do with photons. As light passes through the material, it can slow down or be absorbed, which is physical interference, not a measurement. And then the quantum eraser variations that I've seen rely on quantum entanglement. Quantum entanglement requires quantum superposition to be a real thing. So we're just going further off the deep end with these experimental variations of the double slit experiment. And for the final item in this section, I want to show you where the quantum mechanics user manual is so you can read more about this principle of quantum state superposition. Paul Dirac was one of the original founders of quantum mechanics. This is the third edition from 1948. His book starts with the principle of quantum superposition because this is the concept that makes quantum mechanics what it is. It's also the same concept that quantum computers are completely dependent upon. I want to pick out a few statements from this section that confirm my quantum mechanics description of the double slit experiment, just in case you thought I've gone off the deep end. I want to highlight here that he says a fraction of a photon is never observed. Here he mentions that the principle of superposition of states, or quantum state superposition, is one of the most fundamental principles of quantum mechanics. Here is the section on photons interfering. We must now describe the photon as going partly into each of the two components into which the incident beam is split. Each photon then interferes only with itself. I told you, it's crazy. So this paragraph kind of sums it up, that the superposition principle cannot be explained in terms of familiar physical concepts. So this is an entirely new idea that you've got to get accustomed to, and one that you need to build up an exact mathematical theory, but forget about any detailed classical picture, or I could just say real world picture. You can read this entire section and come up with your own opinion, but what this tells me is forget everything you know, believe these new ideas that are based on math theory. Quantum mechanics is a belief system that's based on math, and quantum computers are based on quantum mechanics. Okay, so that is the end of the first part of this video. Here you can see what we're going to talk about in part 2. And one of the most important points of the next video will be around this, the Born rule. It's this man's idea that allows the concept of quantum state superposition to even exist. So both quantum mechanics and quantum computers rely on Max Born's belief in how the world works. Thanks for listening.